Hi, I'm Akash Joshi. I'm the Aura Guru, and today we're going to be talking about portfolio optimization with nonlinear programming. And I'm going to teach you how to make a mountain of money. Okay, so what is portfolio optimization? Portfolio optimization is just a way to minimize risk when you're investing in the stock market to try and get try and make a profit and get a good return on your investments. Okay, now let's get down to the problem. We want to invest $20,000 of our hard-earned money in stocks. We have three stocks that we're looking to buy: A, B, and C. The price of stock A, $100, price of stock B, $80, and so on. You know how to read the table. The future expected price, so it's a stock, right? We don't really know what the future expected price is, but there are some formulas that you can use to determine what you think the price might be. But remember, these all come with the risk. And I'm going to attach the link in the description for how to calculate this, for how to calculate future expected price with a formula. Okay. What if we wanted to maximize our expected return? Well, this would be simple. If we wanted to maximize our expected return, we would just invest all our $20,000 in stock C because we'd get $25 for every stock we buy. And that would be pretty good. But of course, there might be stock C might be really risky, and maybe because it's risky, it might also go down. So if we're looking to maximize expected return, the formula for that is quite simple, and we can just invest our money in the ratio of we can just invest all of our money in the highest ratio of the future expected price to maximize our expected return. But of course, we're not even considering risk, and that's problematic because stocks are risky. Now let's talk about solving a portfolio optimization problem with risk being considered. Okay, so we have our stocks, we have the prices, and we have our future expected prices. So let's look at stock A here. There's a 75% chance that the stock drops $5 in value, and there's a 25% chance that it increases $15 in value. So to calculate these probabilities, it will require some knowledge about the stock market and some statistical analysis. So that's quite complicated, and I'm not going to get into that in this video. Okay, so back to our problem. So how do we calculate risk? What we're going to do is we're going to use something in probability known as variance. If we calculate the variances will measure the risk. The higher the variance, the more risky the stock is. Okay, so here are the variance formulas for each of the stocks. Now the variance formula is kind of complicated, and I'm not going to get into it because it is a statistical. I'm not teaching you guys statistics. I'm teaching you operations research, and that's my favorite, so I'm just going to stay away from statistics and probability. Okay, so let's look at it. I'll maybe explain a little bit. So right here for stock A, 3/4 is just 75%. And we have our expected value, or not expected value, our future expected price, which is $95. And here is our expected value. You'll notice that these are all the expected values of all of the stocks. And we're going to use these expected values in the variance formula. So what we do is we take the future expected price, subtract it from the expected value, square it, and multiply it by the probability. And then we add it up for each of the probabilities. Over here, we only have two probabilities, 3/4 and 1/4. So we do that whole process and we get 75. So we can tell that this stock isn't very risky. And if you continue down to stock C, you can see that this stock is pretty risky because it has a higher variance. All right, so how do we solve this problem? Let's talk about the objective function. Okay, so over here, we have the risk for all of the stocks times the number of stocks we buy squared. Okay, so why do we square it? Well, this is because the variance formula is squared, and in order to match the risk to the number of stocks we buy, we need to square the number of stocks we buy because variance, which is risk, is squared. So that's just like a pattern you gotta know for portfolio optimization. Just square the number of stocks you buy, multiply it by the risk, and try to minimize the all of those added up. Try to minimize that. Okay, so that's our objective function. Let's talk about our constraints. So we have $20,000. The prices of the stocks are multiplied by the number of stocks that we buy, and all of that added up together has to be less than or equal to $20,000 because $20,000 is the amount of money we can spend, and that's the maximum. Also, okay, so this is the expected value of the stock. We calculated this on the last page, and we used it for our variance formulas. So we multiply the expected value by the number of stocks that we buy, and we have to say that this is greater than or equal to R. Now, the person who creates the mathematical model has to determine R. So if I set R to 22,000, that means at a minimum I should be expecting to make $22,000. And of course there is risk, so I might not make $22,000, but what this does is it makes sure that there's a feasible solution that gives you enough money above $22,000 or $23,000. Basically, you can set R to whatever it is. The higher you put R, if I set R to $30,000, then the riskier it'll be. Okay, so, and of course, the number of stocks we buy has to be positive. Okay, so now all that's left is for you to put the nonlinear mathematical programming model into an Excel solver, and the Excel solver should give you a bunch of feasible solutions. So how do you put that into an Excel solver? Well, you'll have to watch another YouTube video on how to put a programming model into an Excel solver. So once you do put it into the Excel solver, it'll give you a bunch of feasible solutions, and it's not going to give you one solution because it will there will be multiple solutions that follow all of these constraints. And basically, you have to decide what feasible solution to follow. So how do you decide that? So basically, as risk increases, so does expected return. That is a direct relationship. So you have to decide, where do you want to cap off the risk. Me personally, on the curve, I like to do it right here. And this is the numbers that the number of stocks that you buy that follows this amount of risk and this amount of expected return. That's what I would invest in, because as you start to go up more, the expected return will go up, but so does the risk, and you're more likely to lose money at that point. So all these solutions are fine up to like right here. Okay, that's it for today. Thank you for watching. Have a good day. Goodbye.